Rightio. So this video aims to, I made a list, to make sure we're comfortable with constructing arithmetic and geometric recurrence relationships from given information, be able to use recurrence relationships to create sequences that are arithmetic, geometric, or neither, and identify the behavior of a sequence as convergent or divergent, oscillating, and neither. So most of this stuff we're already familiar with. It's this stuff that's really new, and the rest of it is a revision of what we might have seen over the previous months. Okay, so let's go on. So these are questions that are based on the material that was put up on Moodle for revision. So I've just changed some of the numbers so you can then go back and do the revision and get as much as you can out of that. So let's try and make some recurrence relationships. And then we're going to use the relationships to find the first four terms of a sequence. So this is us making recurrence relationships. So here's our first one. Each term increases by 3 as the pattern progresses, starting with 5. So how do we turn that into a recurrence relationship? We're not even looking for the terms yet. We're just turning it into a recurrence relationship. Well, all of these ones are going to start with Tn to say here comes a recurrence. And then to get a term, well, I'm going to say this is the new term that I'm going to be finding, and usually we find this new term by working with the one before. So if this is a term, this here would be the term 1 back. Now in this case, each term increases by 3, so we take the term 1 back and add 3. Now that's how the pattern works. We have to add, and I put a nice neat comma where it's starting with, and that's of course term 1. Term 1 is 5. So what we've done here is state the recurrence relationship with Tn. There it is there. So how does this work? Well, if I wanted to use this recurrence relationship to find some terms, I can put in, I already know what the second term, I already know what the first term is. So I'm going to put T2 in. Wherever I see an n, I'll replace it with a 2 because I'm after the second term. So T2 minus 1 plus 3. Now hopefully what this will do is T2 minus 1 will turn this into T1. So term 2 is term 1 plus 3. And of course we know what term 1 is. Term 1 is 5. Term 2 then is 8. So now I'm going to start listing the terms I've got so far. The first term is 5. The second term is 8. And hopefully if you repeat this process, you put 3 in, and that would become 2. And you find term 3 by going term 2 plus 3. You find term 4 by going term 4 is term 3 plus 3. And this is an arithmetic series that is just each term increases by 3. Do you have to do all this working out? No. We do have to sometimes come up with this. Sometimes, not always. Sometimes it's given to us. Sometimes we have to come up with it. Often it'll only take 1 or 2 steps before you can see. In this case, this one is going up by 3 each time. So the next one's 11. The next one is 14. Arithmetic series are quite nice like that. Alright, so let's have a look at another example. Again, state the recurrence relationship with Tn. So Tn equals something. List the first 4 terms of the sequence. So let's make Tn first. Each term is 1/5 of the term before it, starting at 2625. So we want 1/5 of this term here, the one before it, 1/5 of the one before it. So this is the term before. So if I'm finding term 2, this will give me term 1. And I want term 1 because they've told us that term 1, the starting term, is 2625. Again, T1 is 2625. So again, that's stating the recurrence relationship. There it is there. Now we either make it or we're given it, but either way, once we've got it, we can use this recurrence relationship to find our 4 terms. We've got our first one, 2625. There's term 1. Term 2 is 1/5 of, again, we put 2 in here. That would be our full working. I've just gone down. Oops. Where are you? There it is. Okay. This will turn into term 1. So term 2 is 1/5 of term 1. We know that term 1 is 2625, so we can replace that. Term 2 is 1/5 of 2625. Now that's where I even, this time of the evening, I'm grabbing my calculator. So 1/5 of 2625 is 525. So we've found 525, 525 is our next number. I repeat the process again. Term 3 is going to be 1/5 of term 3 minus 1. So term 3 is going to be 1/5 of term 2. Well, we've got term 2, 1/5 of 525. Again, using my calculator, is 105. And then if you follow the pattern, this is a geometric pattern, and you can tell it's just it's shrinking by a factor of 1/5 each time. It's just shrinking and shrinking and shrinking. So my last number would just be 1/5 of this as well, which would be hopefully 21. And there we go. That's one that's shrinking. Now we are going to look at some other things in a moment, but let's just get through these different kinds. I'm going to move a little quicker this time. Again, write a recurrence relation, state the recurrence relationship with Tn, so Tn equals. Each term is multiplied by -4 to obtain the next term, all right? So -4 times the one before it. Again, this term, the new term, is -4 lots of the one before. And this time, where are we starting? Oh, the starting term is 1, so T1 is 1. There's our recurrence relationship. Now again, I've got my first term. Now I'm going to go T2, finding the second term, is -4 lots of T2 minus 1. So term 2 is -4 lots of term 1, which we know is 1. -4 lots of 1 is -4. Again, if you repeat this process, and you might want to pause the video to see if you can work out what the next number is going to be and what the next number is going to be. I'll give you a second to pause if you want to do that. Okay, so I can see that this is just going to be -4 times each new term. So it's -4 times the term before it, to get the new term. So -4 times that is +16, because -4 times -4 is +16. The next term, -4 times this, would be -64. And you can use your calculator to help you out there. Where we have the first 4 terms of that sequence. And then, oh, no. I've done something creative. No, I pressed the wrong button. Sorry about that. I meant to press this one. So our new page. And here I've just gone straight to the recurrence relationship I want to create. Each term is -3/4 of the one before it, starting at 800. Just making a few little notes for myself there. So the recurrence relationship Tn would be -3/4 of every, -3/4 of every term before. Okay, So in this case, term 2 is going to be minus 3/4 of term 1. Minus 3/4 of term 1. So term 2 must be minus 3/4 of 800. So there's our first term, 800. Oh, I did not finish. Sorry about that. I did not finish my recurrence relationship. What's missing from that? Why would I miss a mark there? I've got the relationship Tn equals minus 3/4 Tn minus 1, but I haven't said where we're starting from. Dang. Let's put that in. T1 equals 800. I know it's up here, but I really should write it all on the one line to say this is my recurrence relationship. So there's our first term, and we found our second term. The 3/4 of 800 is 600, and the negative will make it negative. Your calculator will work that out for you. Now again, this is just going to be minus 3/4 of each preceding term. I'll give you a moment if you want to pause it and see if you can work out what the next two terms are. Of course, I can keep going because you can just unpause it and listen to me waffle on. Okay, so minus 3/4 of minus 600 is 450. And you'll notice because we're multiplying a negative by a negative, it becomes positive here. And then times 3/4 will be times negative 3/4 is minus 337.5. Couple of things about this. Look, they're swapping signs each time. Why? Again, because I've got a negative here, and we saw that just a little bit ago when we multiplied by... Oopsie. No, we didn't. Okay. Sorry about that. 1/5. Negative 4. And here again they were swapping sign. Because when we multiply by a negative, each successive term will swap signs. We're going to return to that idea in a moment. Lastly, I want to look at this one because it looks nuts. You won't be expected to make such a crazy relationship. I mean, there are some classic ones like the Fibonacci sequence, which we have looked at in class and we have explored, but this one we haven't. It's just a crazy relationship. We're not going to tell you to make one quite so crazy. But we can use this to make a number pattern. They've told us term 1, they've told us term 2. So how can those two terms help us to find the next term, which would be term 3? Okay. Term 3. N minus 1. N. There's term 1. There's term 3. So this one's been put up for several different reasons. It's annoying for several different reasons. You can see over here, it's got Tn minus 2, N minus 1. There is Tn. Now if we look at any of the other ones we've had so far, the ones we've created and used, Tn has always been by itself on the left-hand side. Tn, 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 all of them Tn by itself. When we look at this one, Tn, not only is it hiding in the middle, but it's negative. Alright, well, we've been given term 1, we've been given term 2, so we must be after term 3. Let's see what happens when we go hunting for term 3 by putting T3 in, and every time we see an N, we replace it with 3. So this first one is going to be T3 minus 2. This one here is going to be 3 lots of T3 minus 1. This one here is going to be minus 3 T3, so that's what we're after. Minus 5. Now there's an N by itself, so N is worth 3. So 5 lots of 3. Now this, we need to refine these down, so that'll be 3 minus 2, which is term 1, which we know. 3 lots of term 3 minus 1, which is term 2, minus t3, which we're after, minus 5 lots of 3 is 15. Okay, so term 1 we know is 4. Term 2 we know is 7, so we want 3 lots of 7, minus t3, minus 15. Now, our aim is to get this thing by itself, and preferably make it positive, so we know what term 3 is worth. So let's tidy up. 21 and minus 15 can go together to make 6. Now I'm going to minus 6 from both sides. So minus 2 is worth minus 3. Sorry, minus 2 is worth minus our term. So we just swap both signs to make t3 is minus 2. Hoo-wee, that's ugly. So we've got term 1, which is 4, term 2, which is 7, term 3, which is minus 2. This is an odd pattern. Let's see what term 4 is going to do by, again, replacing each of these n's with a 4. So term 4 minus 2 equals 3t4 minus 1 minus t4 minus 5 lots of, there's an n there, so 4. Okay, let's refine this. t2 equals 3 lots of t3 minus t4 minus 20. Now we know what t2 is, it's up here, it's 7. We know what t3 is because we just found it, it's minus 2. So 3 lots of negative 2 minus t4 minus 20. So 3 lots of negative 2 is negative 6. Negative 6 minus t4 minus 20. These two numbers can go together to make minus 26. And then I rearrange by adding 26 to both sides, so it would make 33. 33 equals negative t4. So this one, we swap the signs on both sides, so t4 is worth negative 33. Alright, so what have we covered so far? We've covered... We've constructed some arithmetic and some geometric recurrence relationships from given information. We've used those recurrence relationships plus one really ugly one. Now, because all of the ones earlier on were arithmetic or geometric, and the last one was definitely neither. Okay, now let's identify the behavior of the sequence. This is the new thing. It's either going to be convergent or divergent, and it could be oscillating, or it could be neither, none of the things we've mentioned so far. Maybe not convergent or divergent, nor oscillating. So let's have a look. When we look at our patterns of numbers, have a think about them. This was the pattern of numbers we made from our first recurrence relationship. If we were to make a picture of those numbers, then just a quick one, nothing fancy. Term 1 might be 1, 2, 3, 4. Let's say that's 5, 10, 15, 20. Term 1 was 5. Term 2 was 8. Term 3 was 11. Term 4 was 14, and so on and so on. What we would say about this one is, if we started here, it's moving away from our starting point because it's getting further and further away from our starting point. We would call this one a divergent. Okay, so let's have a look at another one. This one here is our recurrence relationship that produced these numbers here. Now this picture, of course, I'm not going to draw it beautifully to scale or anything, but our first term, term 1, was a very, very big positive number. And then very quickly it shrunk. So term 2, 525, was tiny compared to that. And then term 3, it shrunk even further to 105. And then term 4, which is hiding, there it is 21. Now, we could keep going multiplying by 1/5 each time, and we would get closer and closer to 0 without ever actually touching. We'd just get tinier and tinier numbers. And if you look at this one, that coming closer and closer is called converging. When you're getting closer and closer, sorry, I didn't mean to kick up at the end. When you're getting closer and closer without actually touching, we call it converging. So if it's moving away from a point, we call it divergent or diverging. Divergent. When it's coming closer and closer to a point, we call it converging, like coming together. Let's have a look at this next one. This one, if we draw a picture of it, this time I'm going to put a line in the middle because this one has positive numbers and negative numbers. The first term is a positive 1. The next term is a negative 4. The next one is positive 16. The next one is negative 64. This one, it is going further away from our starting position, but if you look at it, it's swapping positive, negative as it's doing it. And we call that wibbly wobbly shape that's made, we call that oscillating. So we can have ones that are diverging and oscillating because it's wibbling and wobbling. So diverging is still getting further away, and usually if they're wibbly wobbly, it's because you're multiplying by a negative out here, which makes it swap each time. So this is divergent, because it's going further away, and also oscillating. Okay, so let's have a look at the next one. This one here, here's our numbers. Let's make a quick picture again. We're going to need positives and negatives. And we'll start in positive land. The first term was a big number up at 800. The next one was a negative number, getting slightly smaller at 600. Then the next one was 450, getting smaller again. Then 337.5, but negative. And if we continued, this would swap from positive to negative, getting closer and closer and closer. So it's oscillating, but it's not getting further apart. What's it doing? It's getting closer and closer to 0 without ever actually touching. So this one is divergent and oscillating. Now, we're not going to pick you up on getting the order right or wrong, as long as you identify that it is both divergent and oscillating. We don't care if you call it oscillating divergent or divergent oscillating. That's okay. And the oscillating is a wibbly wobbly swapping each time. And last but not least, this ugly thing. Notice how 4, 7, both positive, -2, -33. If we draw a map of that, it's hideous. It starts in positive land, it's 4, then it's 7, then it goes to negative land, 2, and then negative 33. This is going away, then coming back, it's going negative, it's going positive. So this is not divergent, it's not convergent, it's crazy. We just say it is neither. All right, and they are the main points we wanted to get across to help you out feeling more comfortable with, what is it called again? Recursive relationships or recurrence. Okay, cheers.